Hello guys, welcome back to another video. So today in this video we will gonna see how to create a crop zone area map, or basically how to extract the cropped area in a particular season in the Google Earth engine. So we'll be using the multi-temporal Sentinel-2 datasets for the whole season, and then we'll try to extract the, like as you can see on the screen, that we have extracted the this cropped area during a season, because multiple dataset we will use for extracting the, we'll generate the Ndvi, and we'll, based on the Ndvi profile, we'll try to extract the pixels cropped area during a season, and then we'll calculate the area also, how much area is the crop zone area. So this is the Ndvi stack. We will create stacked Ndvi kind of thing, and based on that we will classify the area. So for that you need to have a Google Earth engine, so you have to sign up for that. So we'll go to the code editor directly, and we will be using Sentinel data. So we'll be using the basically multi-temporal Sentinel data, and we'll create the Ndvi, and then we'll stack that data set, and then we'll do the classification. So let me go for surface reflectance, and we will be using the harmonized product of Sentinel. So this is the code editor. Let me just zoom it a bit. So here very quickly we will just create a collection 1, and here we'll use the harmonized version. There is a new product. And then we will filter the date. So we'll be what we will do, we will first select the basically our area of interest also. So I have uploaded the shapefile here. So let me just import the shapefile first, like this. This is the district shapefile. So we will be using the where table. Let me just give dt and table dot filter dot filter dot eq, and we'll be using the we'll be doing the analysis for one district called Bikaner in the Rajasthan state. So we'll write the name of that, Bikaner. So now we have our area of interest also, and now we will do the we will just create the collection of the images, and we will based on the season we will filter the images. So we'll be doing this analysis for the basically for the Rabi season. So we'll take the images from the October 2021 to the till the March 2022. So simply we'll write here dot filter date, so we will create a 15-day composite, Ndvi composite, maximum Ndvi composite, you can say greenest pixel composite for every 15 day, and we will create the Ndvi, then we will stack the images. Like this is the first 15 day, and after that we will do the filter also, dot filter bounds also. So based on our area of interest we will do the dt. Let me just print first. So we'll check first whether we are able to get this or not. So there is error. Okay, so now I think we are able to get the collection. Okay, 48 elements. So like this, first what we will do, we will create the greenest pixel composite for one fortnight, then we'll keep on adding the date. So then what we will do, now we have created the collection. Now we will write a function for add Ndvi. So we'll create the Ndvi, and we will add that band to the particular collection, particular image, all the images inside this collection. We will create the Ndvi, and we can add to that stack basically. So let me just write one function and we will create a variable ndvi is equal to img dot normalized difference. This is the already there is a function of this is the function of defined in Google Earth Engine. You can directly use two bands and it will give you the normalized difference. So we'll use the band 8 and band 4 to create the ndvi. Simple as that. And we will rename it to the ndvi. And after that we will simply return ndvi dot we will return img dot add bands. So what we are doing, it is creating the ndvi and it is adding that ndvi band to the particular image. So for it we will run this function for all the images inside the function. Simple ndvi. So this is our function is ready. Now what we will do, we will run this function to we will map this function to the collection. So we write where add and let me give any name, ndvi is equal to collection1 dot map, and this function will map. So we'll give this name to with ndvi. We'll give the name like this, with ndvi. So now we will collection1 will map this and then we will print this also. We'll see whether it works or not. With ndvi1, I will give the name with ndvi1 to it. And now if you will run, so what it will do, it will take this collection. Like you can see 48 elements, features are there, first image is there, bands, these many bands are there. So now if we see this collection, second one, so what it will do, it will create a ndvi and it will add. As you can see, ndvi it has added. So based on this ndvi, we will create the greenest pixel composite after that. So now this is ready. After that we will create a quality mosaic. So we'll create a function called greenest1 is greenest1 okay is equal to with ndvi dot quality mosaic and we have to give the band name here. So based on the ndvi, we are creating the mosaic maximum ndvi, and after that dot select what all are the bands you want to select from the images. Either you can use all the bands or you can even select the band. So what I will do, I will just give band 2. So we'll use these bands, 3 green, then we'll use red, then we'll use B8 means NIR, and finally we'll use B11, SOIR1 and SOIR2. So these bands we will gonna use for the analysis only. All the other bands we will not use. 12. And after that even you can clip to it your particular area, like for this which we have already defined this DT. So we'll write DT. So now we have created the greenest image also, and after that we will create simple ndvi out of it. So we have created a greenest pixel composite for this collection between 1st October and 15 October. It will take all the images and it will create the maximum ndvi composite, greenest pixel composite, and then we will create the ndvi out of it. ndvi1 greenest1 dot simple as that normalized difference. We will directly use this, and here you can give the name, rename ndvi1. So now we have, okay, there is some error like this, fine. So we can just print it and we'll see. we will print this also. Ndvi 1. So now if we run it, we should be able to get all the images. Okay, this collection 1, collection, okay, 6 band it is showing. So B2, B3, B4, B8, B11, B12, this is fine. And after that we have 1 band Ndvi. So now we have created for one collection. Now we will keep on creating this, just repeating. We will just repeat this collection 2 and simple. Just we will change the dates here, 16 to 31st. So every 15 days we will create one collection like this. We keep on, like for November 1st, November 2nd, whole season we will gonna do this. And simply we just change this collection 3, and here we will give the name this 11 November, then 11, then 15, here we'll use 30th of November, 31, 16, 11, this is fine. Then we will use here 12, 01, 15, 12, here we'll use 12, 31st, this is fine. 16, here we'll just 2. Now here 2022, 01, 01, 15, 01, 31st, 01, just will change the year also, 16 to 30th, this is fine. Now 2022, then 0. So let me check. October 1st fortnight, October 2nd fortnight, November 1st, November 2nd, December 1st, December 2nd, January 1st, January 2nd, and now February 1st means 0. Then we'll choose 02, 22, 22, 15, and here we'll go for 16, 02, 22, 22, 02, and this will be 28, and then we'll do 15, 03, 2022, 2022, 03, and 01, and finally just we have to change here 03, 03. You can add April images also if you want, but I think these are sufficient for it. So okay, 1st March to 15th March, and just we have to change the year here. So now we have our collection. Now just I will this connection. Now we will map for, we'll do the same thing for all the this. So like October with Ndvi 2, just we have to rename it collection 2 in 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10, 11, 11, 12, 12. So October, November, December, January, February, March. So this we will remove. And here also we have to change this also. We have forgot to change the 3, then 4, 5, 6. You can give with the fortnight name also, but I'm just giving like a number. 9, 10, 11, and simplest 12. So now we have with Ndvi. Now again similarly we have to copy this, and we just have to keep on adding this also. October, November, December, January, February, March. So now we have 2, 3 4 5 6 7 8 9 10 11 12. So like this you have to change this all only. So now this is fine, and here finally only we have to do this also. Ndvi again we have to create October, November, December, January, February, March. So this similarly will change all the names accordingly. So now we are done. So now we have all the NDVIs and everything. If we run it, our code should, okay, column, okay, here we have to remove 111. So we'll again run, try to see, okay, there is no error now. So now we have created our NDVIs for each fortnight from October 1st fortnight to the March 2nd fortnight. Now we will stack those. So we'll create stacked NDVI is equal to, simply what we will do, we'll just add the bands, ndvi dot add bands, and we'll just add all the bands together. Ndvi 2 3 4 5 6 7 8 9 10 11 12. So now we have added all the bands together, 12 bands. And if you want to use these bands also, generally what I will do, I used to scale these values, because if you want to download this stack, so we'll scale it and we'll convert it into unsigned 8 bits, so the size will be much smaller. Otherwise this NDVI will be between -1 to 1, so it will be float. So if you try to download this, the size will be a bit on the higher side. So what I will do, I will scale it. That depends on you. You cannot, you should not, you may not scale it, and you can use directly NDVI. Simply you just into 100 plus 100 I will do dot multiply 100, and then I will add 100. So simply if my NDVI is 0.5, so it will become 150. If NDVI is 0.2, so I will multiply it by 120, and then we'll add to 200, so it will do 120. So like this we'll simply do this, and after that I will convert it into int 8 unsigned 8 bit. So now we have our stacked NDVI. So we will add this stacked NDVI map.add layer. Now just use scaled. I will add the scaled one, and I will just simply use, you have to give bands, so you have to use any three dates NDVI. So let me just, so I think I will use October, November, December, January, February. So I will use 9, 6 and maybe 4. Okay, one more thing we forgot, NDVI we have to give the different names also. NDVI 2, so bands we have to give different, NDVI 4, 5, 6, 7, 8, 9, 10, 11, 12. So here what I will use, Ndvi 9, then Ndvi 6, and I will be using Ndvi, let me go for 4. And minimum maximum value you have to give. That what we can do, we can give minimum 100, because we are not because 0 is 100 into 100 into 100 plus 100 will do, so 0 will become 100, and maximum we will take 200, because if Ndvi is 1, so if into 100 plus 100 will become 200. And I will give the name to it, stack Ndvi. So now our stacked Ndvi is ready, and if I run this, I should also, one thing we should do, map dot center object, so we should center our area of interest also, dt. So when I run it now, so it should zoom to that area. Okay, now this is fine. So this is our area of interest, as you can see. Ndvi 9, 6, okay, not 9, we should make it 4 or maybe 3. Let me go for 3. So now you can see this is our stacked Ndvi. So if you, these all are basically agriculture, the crop zone area, which is yellow, and basically you can see the darkish red kind of color. These all are crop zone areas. So we will try to extract. So if you click on any pixel, that pixel, so you'll get this Ndvi value. So if you plot it like this, you can see this Ndvi drop down. So harvesting is there, 1117 means 0.17 Ndvi only. So now again it will start doing like this. So this means this is a crop definitely. But if you click anywhere here, so Ndvi values will be pretty, as you can see here, 115, 114, the values are less than 0.15. So this is not agriculture area. So like this you can differentiate between this, and then you can create the training data sets, and then you can classify. And also if you see here, some, like if I put on this blue color class, so this will be, as you can see, this crop was there during Kharif season, then it got harvested, and no crop was sown in this season. So this is previous season crop. So like this, but we are targeting here Rabi season crop, so we'll go for this kind of profiles where Ndvi is increasing like this 0.7, and then we will try to classify. So for that reference purpose also, what we'll do, we will gonna add one image also to just see the agriculture area. So what we will do, we will any of this greenest, maybe March, February, let me just go for greenest 9. This is the February 1st fortnight. So again we will give the bands, and here we're gonna use B8. We'll create a false color composite, B4 and B3, and we have to give some minimum maximum value. Minimum we will give 0, maximum we will give around 4000 or something. It's fine, I think. And we will just give the name to it, Sentinel Feb first FN. This is fine, and we will just simply add this also. And let me run this. So now you can see the images also, like if you go to this particular area, let me run it again. So for the time being, I just switch off this. I will just comment off it. So if I zoom it and run it, so it should not zoom out. So now if you see this image, yes, So now you can easily see these red pixels all are agriculture area. So we have to extract those pixels. Even these are the very low tones are there. This may be a gram crop, or because soil background is more, so we have to extract these pixels also. So we'll see how to do that. First of all, what we will do, now we have everything. So now we have to create signatures. So for that, what we will do, we have to create some signatures like this. From here, what we will do, like polygon. So we'll create two classes only, because right now we are only targeting cropped area. So we'll take crop and non-crop. Otherwise, if you have a ground data for different crops also, you can create signatures for different crops, such as gram, mustard, wheat, and other crops, other also urban. But right now we are only targeting the crop area, because we don't have any ground information about the different crops. Maybe based on the profile we can do, but right now we are just targeting the total crop. So we'll create crop, and we will give this property class 1, and make it okay. And again another we will create non-crop, or we'll just say it any different name. We can give other name. So we'll just give the name other, simple as that. And feature collection, and we'll just give class, we will give value 0 and okay. So now we'll create the signature. Now let me just run it first. Yes, this is fine now. So now we will create signatures first for crops here. Like you can simply very easily you can create like these all are crops. Even if you go on inspector and if you click anywhere on these pixels, you will see you can see this is the 0.88 and this is the Rabi season crop. Here if you put here, so it will be a Rabi season crop. See this, but this blue pixels would not be. This is all about the color combination, because we are having yellow means we are having high values during the last two RGB. Basically the 9 and 5 is having high values, so it is giving yellow color. Blue color means high value on this Ndvi 3 but lower values here. So it means the crop was there on this date. 3 means in November, but after that Ndvi is low, as you can see when I clicked on the blue pixel. So here it is high value, so, but otherwise it is low values. That's why it is giving the blue color, because we are passing this Ndvi to blue color. So all this combination, and this black means basically there is Ndvi is low throughout the images, all the three. As you can see 115, 114, it is 0.17 Ndvi value only. So like this we can say these all are crop during Rabi season, but this is some other season crop, Kharif season crop, which has been harvested. So like this we will create crop all these signatures, and from here also we can see this is all our crop. And you can put point here also, and you see this is the crop definitely. So we will create another few of the signatures here, here, these all are. So these may be this crop may be different, this crop may be different. If you have a ground data, so you can even give the signatures like this, and then you can classify, do the classification. But right now we are only targeting the crop and non-crop. So based on this signature, now we will go for the other, means this is not a crop, as we have seen the signature. And also this blue, this is a crop but not a Rabi season crop. So right now we are mapping the Rabi season crop, that's why we are giving it to the other. So here we are not mapping the cropland or non-crop land, we are mapping crop sowing area during a season using the multi-temporal data. So during a season, how much is the crop sown area in a particular district or a particular area of interest. So we are interested in that only. So like this, and then we have to check, like here also this is also other. So we'll make other, here also we'll make other, and again we have to go in inspector and see what is this this crop, this is also a crop or not. So as you can see, this is also a crop, how Ndvi is increasing during the season. So we can create the signature from here also, and we have to see this kind of signature also, whether this is a crop or not, like this, because this during this season gram is sown and the soil background is much more. So as you can see, this is also 123 down, then 158. So this is also a crop. So we can take this also. So other, you can create a pretty big profile of other here. This is some other land use, land cover. This is some other, as you can see, this is some other. I think this is not a crop. Let me just verify it. And also you can sometime you can use this satellite base map also. As you can see, this is something, trees and everything. So here also you can verify this is some other barren land or some kind of thing. So you can use background also for that. So now here we have given a lot of signatures. So we have to take signature from some other portions also. Let me just go here and create some signatures. Here we have a lot of images are there, so we can go for crop signature. It's like this is also other season crop. So just to be sure, this is the agricultural land, but this is not a crop sown during a Rabi season. That's why we are taking it as other. Otherwise this is definitely agricultural land, this one, but it has been not sown during this 21-22 Rabi season. So that's why we are only targeting the Rabi season crop sown area using the multi-temporal data. Based on the Ndvi profile, we are just targeting that. And you can give so many other. Here also you can give some of the urban area kind of thing. I don't know this is urban area or what, but this is not a crop. So now if we have to give some very light signals also, as you can see here, very light signatures are also there here. So we have to take these also into consideration, because very less soil background, very actual soil background is more, that's why the signature is low. But definitely this is a crop. As if I let me just click here and see, so this image is basically composite, greenest pixel composite image which we have overlaid. So as you can see here also, this Ndvi 120 and it is going 150.5. so definitely this is a crop. So we have to take the signature of here it's also, but the signature is very weak due to the more soil background, but we have to take this also into consideration. Like this. So now if so we have created a little bit. So first we will try to classify using this, then we can further add more. Like here I will just let me go for other. Here also these other classes. This is, we can take a pretty big one. So now we will create these signatures. Like we'll create GT is equal to crop dot merge other. So now we have merged these two. So as if you see here, you have two signature, crop and other here, and after that we will create the now signatures out of it. How to do that? We will use where training data is equal to which image, from which image we want to extract this Ndvi stacked Ndvi scaled dot let me just see here, you can image, I think sample region or something. There is one PQRS. This one will use sample regions. Yes. So this will create the signatures like this. We will do this. Curly brackets we will give, and collection, properties, scale, and this we will remove. No need of these many parameters. So now collection, we have to give the image name, not image name. This collection, feature collection means this GT, whatever signature we have created, crop and other. So we give like this. Then properties, the name, like we have given this property name, so that we have to give here, just give the class, the attribute name which we have given here, this class name. And scale means resolution, so 10 meter data, so we'll give resolution 10. So now we have created the training data. Now we have to create a classifier. We have to train a classifier. Classifier is equal to, and then we have to go for which classifier you want to use. So we'll go for classifier, ee.classifier, and we will use random forest. You can use any of the classifier, a lot of classifier are given, so we will use random forest. And here we will remove all the things, no need of that, only number of trees we will give. So let me just start with the 100. Then you can use dot train. You have to train this, and classifier dot train, definitely this function we will use, features, class property, and this one we will use inside that dot train. Class property, input property, or we'll remove this thing, no need of these. So these many features means you have to give, what are the features? Features means this one, training data, with sample region which we have created. Simply use this training data. Class property, again you have to give the name of the field, means this one, whatever you have given the class, this one, this name. And input properties, you can give the bands, like if you want to select all the bands, like we have taken those many bands, so then no need to give this. Otherwise you can specify the bands, only selected bands you want to use for classification. Otherwise we will remove this, no problem. So now we have our classifier ready also, and now simply we will just do the classification, where classified is equal to we will simply use image.classify, and you just go to ee.image. This is the docs you can always use if you forgot anything, like .image.classifier. You go in C, so you will see classifier image.classifier. So you have to give like this name, this function we will use. And we will give the image name, which image we want to use. So stacked Ndvi scale, we will classify dot classify. Classifier name you have to give, so this is the classifier name we have given. And output name, file name you have to give. Let me just give classified. So now you have your classified image ready, and you can simply add map dot add layer. So we have two classes only here, so you can use classified, and then you can give color. Let me just give palette white and yellow. So this is the palette, and you have to give maximum minimum value. Minimum is 0 and maximum is 1. So if you are classifying to 5 classes, then you have to give 5 colors here, like for 0 1 2 3 4 5. So you have to give 5 colors, and then after that you can give any name to it. Classified So if I run this now code, so we should be able to get a classified image based on our signatures. So there is some error, let me just, is not defined. Okay, here the naming error is there, classified. Now again we will add. So now we should have a classified image based on our signature. So as you can see, now we have white and yellow. But now what we do to see only yellow pixels, what we can do, one more thing, you can do classified dot, we can create a where classified 1 is equal to classified. So if I want to overlay only one this yellow pixels only, so we'll just create a update mask, and classified dot eq when value is equal to 1. So we'll update the mask, and here we will use the classified 1. Now we should be, and here what we'll do, we'll just remove this color, only yellow color will give, so only one yellow pixels will come now, as you can see now. So I think it is classified a pretty, here if you go zoom it to that particular area, so it has quite nicely extracted the pixels. As you can see here, it has not extracted those areas. And also if you compare with this, so it has not taken these blue pixels. This is the Kharif season crop which has been harvested. Otherwise mostly it has taken. So I think but here if you see, so now this is we have to just check it in some other regions also, like here if we go, we have to check here also. So you can create more signatures if it has left, algorithm has left some of the area, so we can create few more signatures. So we should be able to get the other area, like here it is also fine, but if you see few classes we are missing, like this one. Here we have to see this profile. Okay, this is some other, if you click here, so you see this is some Kharif crop which has been harvested, 156. So but if we click here, so we see 150.5. okay, it has been harvested here, 0.115, 118, 139, again it has grown 181. So this we have to consider somewhere. So here also it is looking like red, as you can see. So definitely this is a crop. So we'll again you can run it like this, so it will automatically. So now I will save this code under my folder, with the name of test. So it has classified quite a bit, as you can see, quite a good classification is there. In some other part also we'll zoom it and we'll see here. So like this you can change this number of trees also. So now we have, as we have classified, we have to calculate the area also. You can further refine more area if you have left some area, so we can do. So further we will create some, as you can see here it is quite classified. I think classification is okay here also, but we have to only see these kind of areas which are pretty, this kind of area we'll have to see only. Like here this is also a okay, 128.3. so the crop is growing but soil background is quite high, so that we have to see whether we want to take these pixels or not. And here it has left some of the area, this also we have to see what is this class. So you can, okay, this is also a crop, so it has missed this. So what we will do, we will create a signature out of it also, again one more. So maybe in a single day you will not be able to see the signature, but in some other image you will be able to see. So that's why multi-temporal data is pretty useful in that case. So like that, after that we will calculate the area. So for calculating the area, let me just copy the code from here directly. This is the code. I will directly copy this and we'll see. Okay, we have to, here we have some other crop, so we have to remove this. Okay, water, we have not taken any area of water, so what we will do, we will take in other this also, because it is the classification is here misclassified is there, so we will take here, so we'll make it other, so this pixel will be removed. Now we will again, okay, so we will again run this. So now this area, we will also use this area, copy, and we will simply copy paste this one. Here we will change the image name, so our classified 1, here classified 1, reduce region is fine, subgroup where group name class geometry is dt, because this district we have to give geometry under which for which you want to calculate the area. So our area of interest is dt only, and here print area. So now if I run this, so it should calculate the area of this particular district also, how much area is there in the class number 1. So it is classified quite good, I think. As you can see, only this very low signature pixels we have to see whether we have to include, otherwise the classification test done here, as you can see. So like this, if you have multi-temporal data, and you can do the crop zone area for a particular season based on the profile, but here we have based some of the data, so we can again create signature here. Like, let me just see first. This is also I think signature of a crop. As you can see how it is a pretty late crop, 137, 165, so it is increasing in the end. So we have to take this also as a, we have to make one more signature, again run it. So now at scale 10, it may take some time to create the area. If you want to check the roughly area, you can, this resolution, if you make it 30, it will very quickly create this area. Otherwise it may take some time to create generate this area. So if I make it 30, so it will calculate the area, but that area will be slightly different, so it may take some time at the resolution of 10 meter. So using the multi-temporal Ndvi images, you can visually correlate. Okay, these are the agriculture zone area during the season. As you can see, we have classified this also. Maybe we have to capture few more signatures here, because as you can see, this is a pretty low scene. These are also agriculture areas, zone area. So we may take 1 or 2 signatures from here, so will be able to capture this area also. So as you can see, we have around this much area. So this is how much area. Let me just go to calculator. This is in the square meters. So if I divide it by 1, 2, 3, 4, 5, 6, 7, so we have this much area, 551,000 hectares, 551,000 hectares. So we can see this much area is there. Okay, if we go to some, let me just go to Google and we'll check the area of this district, and let me go to the Rajasthan Agriculture Department. I think they have some statistics on their website, so we'll see how much area they are saying and how much we are getting. I think here there is somewhere. Okay, let me just zoom it a bit first. horticulture statistics, crop wise sowing area. Okay, so we can see this crop wise sowing area, and Rabi 21-22, this is the area we want to check, Rabi season. Final area Rabi we have here 13-1. Okay, so this is the, okay, which district we want to see? Bikaner district. Okay, so they are saying 588,000 hectare. This is, as you can see here, they're saying Bikaner district, the sown area zone is 588. How much we are getting? So at 30 meter scaling we are getting 551. So if I make it 10, it may improve a bit, but I think we have missed a very small, this, as you can see, this is giving some signature of the crop, because this may be a gram crop which is having the more soil background, so we can take this signature also. So that we have missed. If I click here and if I select this, as you can see, this is giving the profile of that only, but the signature is 128.28. so that's why I have not taken it. Otherwise, if you take this, your area may increase a bit. So right now, if I just simply calculate the scale of 10, so I may get around 560 or something. So around 20,000 still we are a little behind. So this area we are missing. So we can improve after taking few more signatures like this signature. Because as you can see, these are the fields, but I think soil background is much more. That's why we are not able to see the crop. So that's why this is the problem, because remote sensing has a bit of a problem. Like here, when soil background is more, so we will not be able to capture that much. But in this you can very well see the pattern of the field. So definitely this crop is there, but the signature is weak due to the soil background. So now if we see the area, so 540, okay, 546 we got the area. So if I take one or more signature, let me just go for here, let me just first click and we'll see the signature, how it is when it is increasing. But signature is pretty weak, 124.24. So I think we can leave it like this. Otherwise here, if we have some good signature, so we can take, yeah, this is I think 0.28. So it's still, the signature is pretty weak, but it is giving some kind of pattern of the crop. So that's why the ground truth data is very important in the analysis. But based on the temporal signature, we can always identify whether it's a crop or not, some other. So if I make it greenest 9, if I add instead of greenest, okay, greenest 9 is there. So it's a pretty weak signature. So I think we should leave it like this. Otherwise, we may confuse this with the. Let me just try a bit. So this is giving a pretty weak signature, but the pattern, like this is a pretty weak pixels. Soil background is very high. That's why this is the mixed signature kind of thing with the soil. That's why we are not able to capture this. So I think we will leave it like this only. So we are getting the fairly close area around 588. They are saying 540, 550 we are able to reach. So I think this is, we are getting a fair bit of an idea. Here we can check a bit this region whether we are able to capture. Yeah, here we are able to capture. Only this part we are lagging behind. That's why our area. Otherwise, mostly we are able to capture here. Very small fields also we are able to capture, as you can see here. As you can see. So I think the classification is quite okay. So now this is about area, and one more thing you can do after this. You want to see the training accuracy also. Like if you use this training accuracy, you use this line of code, so it will give you whatever signature you have used. If I run this, so it will based on your training dataset, it will calculate the accuracy. So whatever class we have given, how much it has, so it is 99%. So it means training accuracy is around okay, but you can always go for the validation also. So you can use this piece of code for validation, but you need to have a validation. Other polygons also you have to create, like validate. You need to have another GT collection, another GT. Like if I use GT directly right now, GT only if I use here, so it will give me similar, because same points I'm using for the training accuracy and same points I'm using for the validation accuracy. So this point should be different. So what we can do here, I will create new layer. So you need to let me just go for crop validation, and I will give the class only, and I will give the class 1, and another I will create other one, other validation. So validation dataset, you should have different validation datasets. That's why we are creating another set of polygons for 0. I will give like this. So now what I will do, I will just switch off over this thing here. What I will do, I will create few more polygons in other one. Like here I will create other, and here I will simply create polygon, other polygons. Okay, we'll see whether we have this one, this one, this, all our other classes. And also we'll see, go for the blue one, because this is some kharif crop here, this one. So we'll create here also other, and here also we'll go for other, and now we will create few of the polygons for class, for our classified image. Like here, if you can draw anywhere here. Let me go for here, crop validation, validation. So now, and one more, what we will calculate one GT val, and we'll create crop underscore val dot merge. So you need to have two data sets, one for training, one for validation. Like we don't have, so we are creating manually. So now we have merged this also, crop val and GT val. We will create the validation stacked Ndvi sample region. Just we will give the name here like this, GT val, and validated is, we'll classify this again, validation dot classifier. We'll use the same classifier and we'll classify our sample region, these regions, and then test accuracy will create validated dot error matrix. Now if you run this, so based on our these polygons, it will calculate the accuracy of validation also. So training accuracy is in 0.99, around 100%. Validation overall accuracy is fine. So whatever polygon we have given on crop and other crop, so it has classified that as perfectly. So like this, you need to have two set of polygon for two set of ground data or training or test data sets. So like this you can do validation and all those things here. So, and after that, one more thing you can do, like if you use this piece of code here, so what it will do, let me just, it will create the profile of your whatever you have created, those polygons. It will create the profile also. So here, let me just give this GT only, and because GT is our training data set, so I'm using that only, GT1. And here just let me go for GT, and stacked Ndvi scale is fine, and if I run this, I should get let me just remove this. I should also get a chart also, so it will give you two profiles, one for other, one for crop. So as you can see, this is our Rabi, whatever signature we have given. So Ndvi is getting down, then it is increasing again. So this is perfectly crop profile, and other profile is like this. So like this, you have all the things at one go. You have this profile, you have validation accuracy, training accuracy, you have area of 551. So it is quite matching, but few classes again we have to take few of the signatures that we can take. Okay, like we have missed this part, as you can see here. So we have to take this. As you can see, if I click here, definitely this may be a crop. Let me just check. Okay, as you can see, 116, 140, I don't know, it's a pretty long, 154. So this may also be a crop that we have to see. But some different kind of crop is there, because the Ndvi is quite high for the, so we can take this also as a crop, and then again you can run this. Like this it is not classified as a crop because this is blue color. So now we can see here it is classified this also. So like this, visually you can again create, and you can again run the classification. So I will save this code and I will share this code. And there is further another, if you want to generate the area at lower level, suppose block level, so you can do that also, like 514. So what we can do here, for that I will share that code also. So if you have your shapefile, you can upload it here, and you want to further get the area of block level, that also you can do. But right now it is calculating the area of whole Bikaner district. Here also, as you can see, some of the area is still missing, this one. Okay, this is something else, it means. Okay, if we see the inspector, as you can see, single date image, it looks like a crop, but if you go here, it is 160, it is some other thing. This is not a crop because 0.6 values are above always. So like this you can check, but more or less I think our classification is okay, and we are able to capture the major chunk of area. So I will save this code, and I will give the link of this code, so you can basically modify the signatures and all that thing, and you can see this code and you can change the code according to your. So as you can see, it has not classified these areas or any forest or those kind of areas. Like here it has missed those areas perfectly. So basically based on the multi-temporal data, we have identified the crop signature, and we have just, so we can say around 5,550,000 kind of area we are able to capture Sown area in a district of Bikaner. So like as you can see, still this is the signature. I think we should take more so we can have a full-fledged area, because like this is also giving a pretty weak signature kind of thing, but we are not able to capture due to the pretty low signature of it, like this one. So if I add this also, because if you click here, but if I take this area, it may mix with some other. So it's a pretty late Sown crop. As you can see here, it is increasing pretty fast. 120, it is 0.23 value only. That's why I'm not taking. Otherwise, if you take this also, your area may increase and you may be able to because it is in the multi-temporal, it is giving this dark tone, so it may be a crop. As you can see, this is the giving a 0.3, so this is definitely a crop, so we should take this, definitely this one. We have to draw one more polygon, 0.49, so this we have to draw definitely. Because single date you cannot believe, you have to take definitely multi-date only, then only you will be able to get the pixels. So if I run this now, so now we are able to get the pixels, but here and there we are getting the scattered pixels again then. So that we have to see. Still we have this much area we can also take, but the signature is pretty weak, so that's why we have left those areas. But because Ndvi is, it's going up to 0.2, but it's definitely giving a signature of crop. So here if I click here, definitely 141, so this is a crop. I think that we can take this, we can take 0.4 it is giving. So yeah, we have to make one more signature. 0.40 is fine, so we can make another signature there. And if I run this, then it's fine. Now we are able to capture this. This is definitely a crop zone area, but yes, this one. So now we are able to capture a bit more. So I think now this is fine, and 566 up to we are able to get. So I think this is this much is fine. So you can further I will say share the link of this code, so you can change it according to your so you have to change these dates based on your how many dates you want to take. You have to based on your season, like this is as per the Rajasthan or Indian Rabi season, so you can change it according to your basically your area of interest or basically your region, and then you can modify, you have to create your signatures for your as per your need. So I will save this and I will share the link in the description of the video for this code, and you can tweak this code as per your need. So I think that's it guys from this video. Thanks a lot for watching. Please give a thumbs up to this video and please subscribe to the channel. Thank you. Thanks a lot for watching.